Welcome to part 2 of the lecture series on converting fractions, decimals, and percent. In this section, we will be converting decimals to percent and percent to decimals. In the first part of this lecture series, we converted fractions and decimals. We will begin this section with converting decimal to percent. Percent means out of 100. For example, saying that 57% out of every 100 people are in debt is the same as saying 57% of people are in debt. To understand percentage, we will consider a ratio of a number out of 100. We will then write the fraction corresponding to the ratio, followed by the corresponding decimal number. To convert decimal to percent, we must move the decimal point 2 places to the right. This is actually determined by multiplying the decimal number by 100. If we write a ratio 7 to 100, this means 7 out of 100. When we take 7 out of 100, we can write this as a fraction 7 over 100, which could be read as 7 100ths. But this is equivalent to the decimal number 0.07, which is read 7 hundredths. To write the equivalent percent, we would multiply the decimal number 0.07 by 100, which is equivalent to moving the decimal point 2 places to the right, giving us 7%. For our next example, we will look at the ratio 16 to 100. The corresponding fraction would be 16 over 100, giving us the corresponding decimal number 16 hundredths. To write this number as a percent, we would multiply 0.16 by 100, which is equivalent to moving the decimal point 2 places to the right, giving us 16%. Our next example, 81.7 to 100 is our ratio. 81.7 to 100 is the same thing as 81.7 out of 100, so the equivalent fraction would be 81.7 over 100. If we move the decimal point 1 place to the right in both the numerator and in the denominator, we will get 817 over 1,000. In the denominator of our first fraction, 100 has an understood decimal point to the right of the number. If we move the decimal point 1 place to the right, we would use a 0 as a placeholder, giving us 1,000. So 81.7 over 100 is the same as 817 over 1,000. We can write this as the equivalent decimal 817 thousandths, which is 0.817. In order to write this number as a percent, we would multiply 0.817 by 100, or simply move the decimal point 2 places to the right, giving us 81.7%. In this part, we will convert each decimal to percent simply by moving the decimal point 2 places to the right. For our first example, 1.21, if we move the decimal point 2 places to the right, we would get 121%. For the next example, 69.7. In order to move the decimal point 2 places to the right, we will need a placeholder. we will add a 0 after the 7. This does not change the value of the number. Now we move the decimal point 2 places to the right, giving us 6,970%. For our last example, 51, there is an understood decimal point to the right of the 1. In order to move the decimal point 2 places to the right, we will need placeholders 2 places to the right. 51 is the same value as 51.00. Now, moving the decimal point 2 places to the right gives us 5,100%. We will now consider converting percent to decimal. We will use a table to show a process. We will start with the percentage, and then we will write the corresponding ratio out of 100. Then we will write the corresponding fraction and equivalent decimal. To convert percent to decimal, we simply move the decimal point 2 places to the left. To show the process of why we move the decimal point 2 places to the left, we will start with percent. In our first illustration, we will start with 9%. When we say 9%, that is like saying 9 out of 100. Therefore, the ratio would be written as 9 to 100. 9 to 100 may be written as the fraction 9 over 100 or 9 100ths. Therefore, the equivalent decimal is 0.09, which we can read as 9 hundredths because the 9 is in the hundredths place. In our second illustration, we will start with 2.3%. The ratio would be 2.3 to 100, giving us the fraction 2.3 over 100, but if we move the decimal point 1 place to the right in both the numerator and the denominator, we can write the equivalent fraction 23 over 1,000, which is read 23 1,000ths, so that the equivalent decimal is 0.023, which is read 23 thousandths because the 3 is in the thousandths place. Our last illustration is 48.9%. We can write that as 48.9 to 100 as our ratio. Then the equivalent fraction would be 48.9 over 100, which can be written as 489 over 1,000. This will give us the equivalent decimal 0.489, which is read 489 thousandths, since the 9 is in the thousandths place. We will now look at additional examples of converting percents to decimals, but in these examples we will strictly just move the decimal point 2 places to the left. For our first example, there is an understood decimal point to the right of the 7, or in between the 7 and the percent sign. Moving that 2 places to the left will give us the decimal equivalent 0.97. Our next example, 15.3%. We can clearly see the decimal point here. Moving that 2 places to the left gives us 0.153, which is the same as 153 thousandths. In our last example, in order to convert percent to decimal, we must move the decimal point 2 places to the left. But notice that we don't have 2 places to the left. So we will move it 1 place to the left, then we will include another 0 to the left of the 0 we have here as a placeholder so that we can move the decimal point 2 places to the left, giving us 48.0048. We would read this number as 48 10,000ths, since the 8 is in the 10,000ths place. We will now consider an application problem. Last year, 35% of a graduating class had taken at least 7 math courses. Of the remaining graduating class members, 75% had taken 5 to 6 math courses. What percent of the graduating class had taken fewer than 5 math courses? We will first look at the information that is given. 35% of the graduating class took 7 math courses. We are also given that 75% of the remaining students in the graduating class took 5 to 6 math courses. We need to find what percent of the graduating class took fewer than 5 math courses. I will explain using steps. We will begin with the explanation, and then I will give the calculations. Step 1. We are given that 35% of the class took 7 math courses, and percentage, as we know, is out of 100. This means that 35 out of every 100 students in the class took 7 math courses. When we subtract 35% from the full 100%, we are calculating the percentage of the graduating class who took fewer than 7 math courses. That is, 100% minus 35% equals 65%. This means that 65% of the class took fewer than 7 math courses. Step 2. It is given that 75% of the remaining class members took 5 to 6 math courses. We must multiply 75% times the 65% of the remaining students who took less than 7 math courses to determine what percentage of the whole class took 5 to 6 math courses. We first change the percentages to decimals and then multiply. Finally, we change the decimal back to percent. So we multiply 0.75 times 0.65. Remember, 0.75 represents the 75% of the remaining class members who took 5 to 6 math courses, times 0.65, which represents the 65% of the remaining students who took less than 7 math courses. This gives us 0.4875. Moving the decimal point 2 places to the right gives us 48.75%. This means that 48.75% of the whole graduating class took 5 to 6 math courses. Step 3. We know that 35% took 7 math courses, and we determined that 48.75% took 5 to 6 math courses. Now we add the two percentages to find the total percentage of the class who took more than 5 math courses. That is, 35% plus 48.75% is equal to 83.75%. We found that 83.75% took more than 5 math courses. Finally, subtracting the percentage of students who took more than 5 math courses from a whole 100% gives us the number of students who took fewer than 5 math courses. 100% minus 83.75% equals 16.25%. Therefore, we found that 16.25% took fewer than 5 math courses.